Hello, ninth grade extended students. Today we are going to talk about measuring angles. Let's start off with a formal definition of angle. An angle is the union of two rays that have the same endpoint but are not both subsets of the same line. So you can see I have ray QP here and ray QR. They both have a common endpoint, and this is an angle. If 3 points P, Q, and R are not collinear, then the union of the rays, QP and QR, is an angle with vertex Q. This angle is denoted by either angle PQR or angle RQP. So notice that those are two names for the same angle. The vertex is always the middle letter. So the angle is the union of those two rays. Now, just so we know that our vertex is the common endpoint here, Q, and we have sides of the angles. So this is a side, and this is a side. So again, we name it with the vertex letter in the center. When there's no confusion about what angle we might mean regarding a vertex, we can just name this angle Q as well. Sometimes you might see that people put numbers inside angles. We could also name that angle angle 1. In traditional geometry, an angle is defined this way: a figure formed by two rays with a common endpoint, and you can see that this definition is pretty much the same as the EMF definition, except that this will allow an angle to be a subset of a straight line. So I could, in traditional geometry, say that angle ABC is an angle. And we actually call it a straight angle. But our book is not allowing for a straight angle. So the next thing I want to talk about is circular orientation. So we say that for distinct points A, B, and C, meaning they are all separate points, none of them are the same point on a circle, the ordered triple ABC has a positive orientation if the motion on the circle from A to B to C is counterclockwise. We say that ABC has a negative orientation if the motion from A to B to C is clockwise. So remember, counterclockwise is positive, and clockwise is negative. So let's take a look at this ordered triple over here on the right. PRQ. PRQ. So I'm moving the opposite way the hands of a clock move. So that is a positive circular orientation. This one is positive. If, on the other hand, I look at PQR, let's see, PQR, notice it's going the same directions as the hands on a clock, so that would be negative, which seems a little counterintuitive. So counterclockwise is your positive, clockwise is your negative. How do we measure an angle? Well, let's see. We do it by looking at the coordinates on a circle. So if I want to know the measure of the angle, I can compare the coordinate of point P with the coordinate of point Q and just subtract P minus Q. My circle has a U radius of 1, so you can imagine that I have the circular ruler on here with unit measurements, and all these coordinates are assigned. Let's see how the coordinates are assigned. So you can see here that I have a circle. It's on a number line. And you can imagine I can take this circle and roll it around along the line L and label those distances when I hit them. take a minute and watch this. Let's see. So the circle's rolling around. There's 1, 2, 3, and halfway around is pi. Okay, so halfway around the circle would be pi, and actually we say that those are radians. In trigonometry and higher level math, it's more common to work with circles with a radius of 1. That way we can assign angles along that circle as we go, or coordinates along the circle. And notice that the circumference of a circle is 2 pi r. So if I were to take this circle and roll it along this number line, I would assign numbers from 0 to 2 pi because the radius is 1. So what is u circumference? U length of a circle is u circumference of a circle. So if you were to take and measure all the way around that outer edge, that's the u length of a circle, and it's also the u circumference. In other words, circumference in unit u. If the circle starts at the origin and after one full revolution arrives at the point P, then the u circumference of the circle is the distance between O and P. That is the u length of the segment OP. So I've taken that circle, I've rolled it all one full revolution along my line. It started at O, it ended at P. Whatever this length is here is the distance around the circle, and that is the circumference of the circle. I mentioned earlier that in trig and upper level math we use a measure of angles called radians. You're used to seeing degrees, but the way we define the radians is the arc length of the unit circle. So if I assign coordinates from 0 to 2 pi, I can look at a circle and know the measure of the angle by studying this. So that's not the best circle I ever drew. Let's try it again. That's a little bit better. So if I have an angle drawn this way, whatever these two coordinates are, I can find the angle in radians as long as I've assigned them based upon from 0 to 2 pi, that unit circle. So I would just subtract my coordinates. So let's say that this is 0, and this is, I don't know, pi over, let's make it pi over 3. That angle would be pi over 3 minus 0, or pi over 3 radians. So as we define an angle measure in terms of a circle, we have that vertex on the center of the circle, and then we simply subtract the coordinates of the circle that we found by rolling that circle along a number line. So radian measure is very important in advanced math, as I had said earlier. However, it does have some disadvantages for everyday use. So the measure of all common angles are irrational because any fraction of a circular orientation is an irrational number. So if you think about that, and you have this circle that has rolled along that number line, this would be 0, the 90-degree angle would be pi over 2, 1/2 revolution is pi, and then I'd have 3 pi over 2, and finally 2 pi. So any common angle, 1/3 of a circle, half of a circle, 5/6 of a circle, is going to be an irrational number. So another way we can measure angles is in degrees. And we set up the coordinates to be one revolution to be from 0 to 360. Now, why 360? Nobody really knows, but that is what the ancient Babylonians used to measure angles. So we call this unit length a u degree, or UDEG for short. Again, there are 360 units for one full revolution of the circle. So the distance in u degrees, O to P, from here to here is 360 degrees. So one revolution of that circle would take me from 0 degrees to 360 degrees. And you can see that if I rotate halfway around, that's 180 degrees. And one full revolution is 360 degrees. Again, when we measure angles, we are simply subtracting coordinates. So if I say I had this angle, and I wanted to know the measure, you can see that one coordinate is 315 and the other coordinate is 360. So that angle would be 360 minus 315, or 45 degrees. So, proposed method to measure an angle, just like what I've been saying. So if I have my angle drawn with the vertex on the center of my circle, I look to see where those sides intersect my circle. So you can see here that C intersects ray BA at point P. My circle C intersects ray BC at my point Q. And then we can use the coordinates to find the measure. So again, let me go back to the beginning. Let A, B, and C be non-collinear points in a plane pi. Let U be a length, and C be a circle in pi with U radius 1. That's the unit circle. And center B. So notice that vertex is right on the center of my circle. We're going to let the U degree coordinates of P and Q be P and Q respectively. So we look at what the coordinate is here and what the coordinate is here, and we got those coordinates by rolling that circle along the number line, measuring from 0 to 360. We propose to define the U degree measure of an angle ABC as the absolute value of P minus Q. And we denote this by M sub U dash DEG, angle ABC. Most of the time in traditional geometry, you'll just see it written like this. EMF is very specific. It wants to state what the units are right there, so it's very clear. So there is a problem with this kind of measure. It's ambiguous. So the problem is that it kind of depends on which coordinates you subtract. If I look at this outside angle, it's going to be 360 minus whatever this is. So which one is the measure of the angle? So it's going to be different based upon the circular orientation of the points with that origin. So depending on the location of the origin and the circular orientation, the result measurement is either x degrees or 360 minus x degrees. And that's a problem because we really want our angles just to have one measure. So we need an agreement to eliminate that ambiguity. So this is what is done. We're going to let A, B, and C be non-collinear points in a plane, and we're going to let U be a length and C be a circle in the plane with U radius 1. So we're looking at our unit circle, and it has a center B. We're going to let P and Q be points such that my ray BA here intersects my unit circle at P, and my ray BC intersects my unit circle at point Q. Then we're going to let the U degree coordinates of capital P and capital Q be lowercase p and lowercase q. So I have coordinates P and Q there. Both of them are between 0 and 360. Then the U degree measurement of angle ABC, denoted like that, is the smaller of the absolute value of P minus Q and 360 minus the absolute value of P minus Q. So we're only going to be looking at angles that are between 0 and 180 degrees. So we're always going to pick the smaller of the differences. So now I would like you to take some time and work on the problems that I've posted on Schoology. These problems are exercises 94 through 98. Have a great day.